Okay, so this video is a continuation of the last one, and it goes over similar problems, similar problems to the last 4 problems on your worksheet. So here we have 3 factors. We need to set each one of them equal to 0 to solve. So I get x equals 0, x plus 5 equals 0, so x equals -5. And then x minus 2 equals 0, so x equals 2. Each one of those I'm going to locate on my x-axis, right, my number line, and I'm going to use a solid dot because there's an equal sign. So 0 is easy to locate, 2 is easy to locate, and 1, 2, 3, 4, 5, -5. So now if we take a look at how many sections we've divided our x-axis into, we have 4 sections to test. So we're going to start off with the number 1, and we're going to try out -6 in this. So we get -6 times -6 plus 5 times -6 minus 2 is less than or equal to 0. So we get -6 times -1 times -8 is less than or equal to 0. And I know that -6 times -1 is 6. 6 times -8 is -48 is less than or equal to 0. That is true. So I'm going to shade that in. In region number 2, I think the easiest number to pick is -1. So I'm going to say -1, -1 plus 5, -1 minus 2 is less than or equal to 0. So I get -1 times 4 times -3 is less than or equal to 0. -1 times 4 is -4. -4 times -3 is +12. 12 is not less than or equal to 0. So in region 3, the only whole number we have is a +1, so I'm going to try +1. So 1 plus 5 and 1 minus 2 is less than or equal to 0. So I get 1 times 6 times -1 is less than or equal to 0. So 1 times 6 is 6. 6 times -1 is -6 is less than or equal to 0. That's a true statement. So I'm going to shade that region in. And then I'm going to pick something from region 4. So I like the smallest number, so +3. So I'll have 3 times 3 plus 5 times 3 minus 2 is less than or equal to 0. 3 times 8 times 1 is less than or equal to 0. That's going to be 3 times 8 is 24 times 1 is 24 is less than or equal to 0. That's false. So I only have 2 regions here that are true. So this one has an endpoint of -infinity. So -infinity always has a parenthesis. Because it's a solid dot, I'm going to put a square bracket. The next 2 have solid dots as well. Square bracket. And then I'm going to use a U. All right, how would you do this next one? It's not factored. Well, we do have 4 terms. So we're going to factor by grouping. So I'm going to look at the first 2 terms, and I'm going to factor out a 16x squared. So I get an x plus 6. And then for the second 2 terms, because there's a leading negative, I'm going to factor out a -25. So I get an x plus 6 again. So I'm going to take this x plus 6 out, x plus 6, and I'm left with 16x squared minus 25, which I know this is not prime. That is the difference of squares, because 16x squared is a perfect squared and 25 is a perfect square. Well, what squared gives you 16x squared? 4 and x. What squared gives you 25? 5. So when I finish factoring that, I get 4x plus 5 and 4x minus 5. And when I set each of those equal to 0 and solve, I get x equals -6. 4x plus 5 equals 0. I'm going to subtract the 5. 4x equals negative 5. So x equals negative 5/4. And when I do the same for the last, equals 0, I'm going to add that 5. So I get 4x equals 5. When I divide by 4, I get x equals 5/4. That's 1 1/4. So here, I don't have an equal sign in my inequality, so I'm going to use open circles. I'm going to find negative 6. 1, 2, 3, 4, 5, 6. Negative 6. Put a nice open circle. I'm going to locate negative 5/4, and I don't have to be exact, but I should be close, and positive 5/4. And again, I have 1, 2, 3, 4 regions. So I need to test from each region. So I'm going to pick negative 7 from this region. And instead of using this big unwieldy polynomial, I'm going to use my factored polynomial. Okay, so I'm going to say negative 7 plus 6 because it just seems so much easier. 4 times negative 7 plus 5. 4 times negative 7 minus 5 is greater than 0. Well, I get a negative 1. Negative 28 plus 5 is negative 23. Negative 28 minus 5 is negative 33 is greater than 0. What kind of a number is this going to be? This is going to be a negative times a negative is a positive times a negative is a negative. This is going to be a negative number that I don't really need to figure out. Negative numbers are not greater than 0. So this is false. I will not shade that region. So now let's find a number in region 2 to test. I'm going to choose negative 2. So I'm going to say negative 2 plus 6, 4 times negative 2 plus 5, and 4 times negative 2 minus 5 greater than 0. I get 4. That's going to be negative 8 plus 5 is negative 3. Negative 8 minus 5 is negative 13. So this is going to be a positive times a negative is a negative. A negative times a negative is a positive. So we get a positive number greater than 0. All positive numbers are greater than 0. So I'm going to shade this region. And then region number 3. Let's pick 0. That just seems easy. So I'll get 0 plus 6, 4 times 0 plus 5, 4 times 0 minus 5 is greater than 0. I get 6. 4 times 0 is 0 plus 5 is 5. 4 times 0 is 0 minus 5 is negative 5. So this is going to be a positive times a positive is a positive, times a negative is a negative. A negative number can't be greater than 0, so that one doesn't get shaded. So now let's plug in 2 from region 4. We get 2 plus 6, 4 times 2 plus 5, 4 times 2 minus 5 is greater than 0. That's going to be 8. 8 plus 5 is 13. 8 minus 5 is 3. They are all positive numbers, so I'll get a positive number greater than 0. That is definitely a true statement. So I'm going to shade that in. And then when I convert to interval notation, remember parentheses for open dots, negative 6 to negative 5/4, union, positive 5/4. The end of this interval is infinity. And I have my solution graphed and an interval notation. Whoops. All right. So let's do this one. So this is one that we're going to go ahead and factor because the exponent here, is half of the exponent here. So when we factor, we're going to find factors of positive 36 that add to negative 13, and I would say negative 9 and negative 4. So remember, I'm going to use the x squared x squared minus 9, x squared minus 4 is greater than or equal to 0. And these are differences squares, so I get x plus 3, x minus 3, x plus 2, and x minus 2 is greater than or equal to 0. So when I solve and set these equal to 0, I get x equals negative 3, positive 3, negative 2, and positive 2. So I'm going to put those with what kind of dots? Solid dots on my number line. So negative 3 with a nice solid dot, negative 2 with a nice solid dot, 2 with a nice solid dot, and 3 with a nice solid dot. So again, I'm going to use my factored form here. Actually, I think I'm going to use this one. And I have 1, 2, 3, 4, and 5 regions to test. So we got to hop to it. So I'm going to say negative 4 on this. And negative 4 squared, if I'm using this guy right here, negative 4 squared is 16 minus 9. 16 minus 4 greater than or equal to 0. Well, that's going to give me 7 times 12 is greater than or equal to 0. And that's true because 7 times 12 is 84. So I'm going to shade this one in. All right, that gives me a positive number. So I'm going to pick a number between negative 3 and negative 2. So I'm going to pick negative 2.5. So when I square negative 2.5, I get 6.25 minus 9. And 6.25 minus 4 is greater than or equal to 0. This is going to be, let's see, a negative 2.75. This is going to be a 2.25 greater than or equal to 0. And negative times a negative positive is a negative number. Negative numbers are not greater than 0, so that one's false. So in region between negative 2 and 2, region 3, I'm going to pick 0. So 0 squared is 0 minus 9. 0 squared is 0 minus 4 is greater than 0. And negative 9 times a negative 4. Well, that's going to result in a nice positive number. And positive numbers are greater than 0. So I'm going to shade this region in. Then I'm going to check 2.5. So I get 6.25 minus 9 and 6.25 minus 4. And it looks like I'm going to have the same answer as this one because I got the same thing. So that one's going to be false. So now I'm going to try 4. So 4 squared is 16 minus 9. 16 minus 4 is greater than or equal to 0. That one looks like this one. So that one turned out to be true. So I'm going to shade that in. And when I write interval notation, I'm going to get negative infinity to negative 3 with a bracket. Negative 2 to 2, both with brackets. And then union 3 to infinity with a parenthesis. All right. So we're not going to have time to finish this one. I'm not going to do all of it, but I am going to factor it. I want you to notice that these are different of perfect squares, right? So this factors into x plus 7, x minus 7, x plus 1, and x minus 1. All right. So now when we solve, we get negative 7, positive 7, negative 1, and positive 1, and we just need to locate those on our x-axis, but this time we're going to do open dots because we don't have an equal. 1, 2, 3, 4, 5, 6, 7, negative 7, negative 1, 1, and 7. Okay, and we have 1, 2, 3, 4, 5 regions. In region 1, I would test negative 8. In region 2, I would test negative 2. In region 3, 0. Region 4, I would test 2. And region 5, 8. And that's all I have time for.